Timeless concepts from Physics Helpline. In this video tutorial, we will discuss an integer type question taken from JEE Main mathematics question paper of 2023. The question is based on a first order linear differential equation which is to be solved by making use of the integrating factor and finally evaluate a given expression. Read the question carefully. Let y is equal to yx be a solution of the differential equation x cos x into dy plus xy sin x plus y cos x minus 1 into dx is equal to 0, 0 less than x less than pi by 2. If pi by 3, y pi by 3 is equal to root 3, then the modulus of pi by 6 y double dash pi by 6 plus 2y dash pi by 6 is equal to dash. We are required to fill in this blank with an integer. Now for the solution. Now this is the differential equation given in the question. X cos x into dy plus xy sin x plus y cos x minus 1 into dx is equal to 0. Now dividing throughout by dx, we get x cos x dy by dx plus xy sin x plus y cos x, and we have taken that minus 1 to the RHS. Now we can rewrite this as x cos x into dy by dx plus x sin x plus cos x into y is equal to 1. Now dividing throughout by x cos x, we get dy by dx plus x sin x plus cos x divided by x cos x into y, which is equal to 1 divided by x cos x. This is of the form dy by dx plus py is equal to q. Therefore, integrating factor is given by e to the power integral of p dx. Now we will evaluate the integral p dx first. Therefore, integral p dx becomes equal to integral of x sin x plus cos x divided by x cos x into dx. Now let us multiply the numerator and denominator by sec square x. Therefore, the integral becomes x sec x tan x plus sec x divided by x sec x into dx. One can easily see that the numerator is the derivative of the denominator. Therefore, the integral becomes d of x sec x divided by x sec x, which is equal to log of x sec x. Mind you, this logarithm is the natural logarithm. Therefore, the integrating factor becomes e to the power p dx. Integral p dx is this. Therefore, e to the power log x sec x, which evaluates to just x sec x. Exponential and logarithm are the reciprocal functions, opposite functions. So we get the integrating factor as x sec x. Therefore, the solution to the differential equation is given by y into integrating factor is equal to integral of q into if dx plus c, the constant of integration. Putting the values, we get y into if is x sec x, which is equal to integral of q, that is 1 by x cos x, into if integrating factor is x sec x into dx plus c. Now x and this x gets cancelled and sec x by cos x gives us sec square x into dx plus c. Integral of sec square x is tan x. Therefore, we get yx, or we can write xy sec x is equal to tan x plus c. It is given in the question that pi by 3 y of pi by 3 is equal to root 3. That is what we have written here. This means that because y is equal to yx, therefore x is equal to pi by 3. This implies x is equal to pi by 3, which gives y pi by 3 is equal to 3 root 3 divided by pi. We have marked this as equation 1. Therefore, putting the values of x and y there in the equation 1, we get pi by 3, x is equal to pi by 3, y replaces y of pi by 3 into sec pi by 3. Sec x is sec pi by 3, which is equal to tan x is equal to tan pi by 3 plus c. Putting the value of y pi by 3 is equal to 3 root 3 by pi, we get pi by 3 into 3 root 3 by pi into sec pi by 3 is 2, which is equal to tan pi by 3 is root 3 plus c. Now pi and pi gets cancelled and 3 gets cancelled, which gives us 2 root 3 is equal to root 3 plus c, which implies c is equal to 2 root 3 minus root 3, which is equal to root 3. Putting c is equal to root 3 in equation 1, we get xy sec x is equal to tan x plus root 3. Dividing throughout by sec x, we get xy is equal to tan x divided by sec x plus root 3 divided by sec x. Simplifying, we get xy is equal to tan x by sec x is equal to sin x plus root 3 by sec x is equal to root 3 cos x. Differentiating, we get xy dash plus y LHS, which is equal to sin x derivative is cos x and cos x derivative is minus sin x, therefore we get minus root 3 sin x. Again differentiating, we get xy double dash plus y dash plus derivative of y is y dash is equal to cos x derivative is minus sin x and sin x derivative is cos x, therefore minus root 3 cos x, which simplifies to xy double dash plus y dash becomes 2y dash is equal to RHS remains the same. Therefore, putting x is equal to pi by 6, we get pi by 6 y double dash of pi by 6 plus 2y dash of pi by 6 is equal to minus sin x becomes minus sin pi by 6 minus root 3 cos x becomes cos pi by 6. Now the modulus of this will be equal to the modulus of this, which is equal to minus sin pi by 6 is minus half minus root 3 into cos pi by 6 is root 3 by 2. The modulus of this will be equal to, this is equal to minus half minus 3 by 2, which is equal to modulus of minus 2, which is equal to 2, which is the answer to the question. Therefore, we need to fill in this blank with the integer 2. This completes the answer to the question. Thanks for watching.